In pursuit of sharing technical knowledge and just to gear up the new generation of engineers, myself Pranav is here to deliver today's presentation, Power Transformer Part 39. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with basic arrangements for regulating windings of OLTCs. There are 5 basic tapping arrangements are shown in figure 131 and of which each have their own advantages and disadvantages depending on their respective application. In every phase of effective on-load voltage regulating tap changer mechanism is hereby made to conclude different occurring process of circular current when voltage is regulated to higher or lower values. Different prospective choice of action is also to be deployed for limiting measures of circular current which is resulted in the process of changing tap point. As of 131 figure, these tapping arrangements are applicable to 2 winding transformers, auto transformers, and to phase shifting transformers, where the tap winding as well as the OLTC is thus to be inserted in the winding at high voltage or low voltage side depending on the transformer design or as per customers' required specifications. Now see the diagram. One is linear, A, B is single reversing changeover selector, that is plus and minus switching, double reversing changeover selector, single coarse changeover selector, multiple coarse changeover selector. As of figure 131A, the linear arrangement is generally applied for smaller tapping ranges and is used on power transformers with moderate regulating ranges up to a maximum of 20% of nominal voltage. It is rather made to be restricted to smaller ranges as because there are difficulties in bringing out a large number of tapping leads from the winding. Bringing out larger number of tappings from the winding that would have been resulted to impose higher amount of impulse voltages across a large number of tapping turns. The tapped turns are added or subtracted in series with the main winding and changes the transformer ratio. Such type of regulation would have to ensure smallest ohmic losses. In linear switching arrangement, no changeover selector is used and has to provide a simpler form of construction with having low losses. As a matter of fact, it acts like a linear potentiometer, which changes the output voltage linearly with the number of tapping. Design and construction simplicity would have been the main advantage of a linear tapping arrangement. Now, as of figure 131B, that is the reversing arrangement that can be used for larger tapping ranges Such type of arrangement is the most common type of regulation where a reversing changeover selection can be made, that is plus and minus switching, would have to allow doubled tapping range. The reversing operation is so far been done by using a changeover selector which would have become a part of the tap selector or of the selector switch, arcing tap switch. The rated position is normally at the mid position or neutral position. The changeover selector that would have to allow the taps to add or subtract from the main winding, and also it is being effectively having the number of connections causing a larger tapping range from a smaller tap winding. Again, I repeat, the changeover selector that would have to allow the taps to add or subtract from the main winding, and also it is being effectively halving the number of connections, causing a larger tap range from a smaller tap winding. Regulated winding is connected with the main winding in series, and the total number of taps are thus to decrease or increase depending on the respective position of tap selector. This has been configured with boost and buck type connection so as to enable the system of increasing the regulating range or decreasing the number of tapped windings. Boost type connection has made the system of a vectorially addition to main winding, whereas buck type connection has made vectorially subtraction to main winding. So, the case of regulating range would have been doubled or the number of taps would have been reduced. During operation of the reversing changeover selector, the tap winding would have been disconnected momentarily from the main winding. Most important. At that position, a potential connection is thereby imposed on the tap winding, which is to be determined by the voltages of the adjacent windings as well as by the coupling capacities to these windings and to grounded parts. This potential as developed is something different from the potential of the tap winding before the reversing changeover selector operation. However, subject differential voltages are thus to be designated as the recovering voltages at the opening contacts of the changeover selector, and when reaching critical level, they are liable to cause inadmissible discharges on the changeover selector. Such happenings may have to arise certain phenomenon of occurring a severe copper losses, as because at that particular position there would have been a minimum number of effective turns. Now, points to be noted: power flow regulation method based on phase shifting transformer is the worst victim due to the incidence of high recovery voltage. As of the modern perspective of three-phase electric transmission network, which is predominantly of inductive characteristics has mostly preferred to use phase shifting transformers to control the flow of active power in the system. By introducing phase shifting transformer, an active power flow between source and load must be accomplished with a phase lag between the terminals. This has been typically done by regulating the voltage phase angle difference between two nodes of the system, that is source and the load, that is source side and the load side. Main guiding factor that has to depend on a phase shifted voltage source injection into the line load by a series connected transformer which is fed by a shunt transformer. Phase shift control strategies are thus to be implemented only by proper interfacing of the actual compositions as regards to shunt and series transformer unit configuration for the active power flow control ability. Phase shifting transformers are often used to regulate the phase angle between the voltages of the source and load systems by varying the tap changing positions. Being the interconnection of large systems, the required number of tap changing operations of phase shifting transformers are normally be of much higher than that of other regulating transformers in networks. However, for phase shifting transformer with regulation at the line end, see the figure 132, there may have the possibility to occur high recovery voltages as due to their winding arrangement. See the diagram. One is source side, another is load side. Phase shifting transformer, that is direct circuit arrangement. Methods of potential connection, that is reversing changeover selector in mid position. The high recovery voltages that would have to occur as due to the persistence of transient voltage stresses over the tapping ranges. Therefore, tap changing operation in this situation might have been quite hazardous, as because the recovery voltages appearing at the changeover selector contacts would there be in the range of the system voltages on the source and the load side. Such phenomena might have been restricted by introducing nonlinear resistors in the circuit. The most accomplished method so far been established is to provide tie-in resistors as the potential connection of tap windings. As of figure 133A and B, it is made to connect the tap winding to a fixed potential by a fixed tie resistors RP or by a tie-in resistor RP, which is only inserted during changeover selector operation by means of a potential switch SP. As of figure 131C, the double reversing changeover selector is a simple but reliable technology as a preventive and curative control strategies as regards to nullify the high recovery voltages by avoiding any sort of disconnection of tap winding during the changeover operation. Particularly in case of phase shifting transformers, the basic problem of the recovery voltages as appearing at the changeover selector contacts are thus to be solved by implementing changeover operation by means of an advanced retard switch, which is called shortly in a short form ARS, advanced retard switch. As of figure 134, addition of ARS unit that has to allow the changeover operation such as made to be carried out in 2 steps without interruption. Implementing this sort of arrangement may have to keep the tap winding always be connected to the desired potential during the entire changeover operation. See the diagram, phase shifting transformer, changeover operation by means of an advanced retard switch, ARS. At source side, at load side, both side ARS is implemented. As the method being relatively complicated, so it is rather recommended for the application only for high rating phase shifting transformers. A phase shifting transformers, which is also to be known as phase angle regulator, is a specialized type of transformer. It has been deployed for controlling power flows and for solving unexpected grid congestions in transmission networks up to 400 kV level. The phase shifting transformer has to comply grid optimization for higher rating transmission network, which offers excellent features in terms of the ability to control active power flow while operating by using reliable load tap changers and advanced retard switch. As of figure 131D, coarse changeover selector or coarse oblique fine switching arrangement would have to require much more complicated winding layout, as because the regulation is to be made with 2 windings, that is regulated winding and inserted coarse winding. Arrangement of coarse or fine selector that has the electrical length of the fine tap winding plus 1 step further. So, in this type of switching, the changeover selector has therefore to extend the regulating range to twice the voltage of the tapped winding. The total operation would thus to be implemented by connecting or disconnecting the coarse regulating winding. Similar to reversing changeover selector, the same type of effects would have been entertained during disconnection of tap winding from the main winding. It is mainly due to the presence of leakage impedance of tap winding or coarse winding during the operation of the diverter switch when passing the mid position of the resistor type OLTC. As of figure 135, the diverter switch or arcing switch, while stirred to operate from the end of the tap winding to the end of the coarse winding and vice versa, passing mid position rather, all turns of the whole tap winding and coarse winding would thereby be inserted in the circuit. As of figure 136, where the diverter switch, that is arcing switch, will start to operate through any tap position beside mid position, then the leakage impedance as of one step would inevitably be much less than that of the case as of figure 135. From the circuit configuration as exhibited in figure 135, it is being obvious that the presence of higher impedance value in series with the transition resistors would have an effect on the circulating current IC, which is flowing in the opposite direction through coarse winding and tap winding during diverter switch operation. Such consequence that would have to initiate a substantially higher leakage impedance value in the circuit. Thereupon, an occurrence of phase shift between switched current and the recovery voltage would have taken place at the transition contacts of the diverter switch, which has resulted in an extended arcing time. However, as of figure 136, where the copper losses would have been the lowest at the exhibited position, were to have the lowest effective number of turns. See the diagram. Effect of the leakage impedance of coarse winding or tap winding arrangement. Transition resistors, IC is the circulating current, where tap selection is bleached, shown in the dotted line. Is figure 136. Is resistor type OLTC. As of figure 131E, where multiple coarse or fine changeover selector arrangement would have been shown. Mechanically, coarse or fine switching has to be carried out exactly as the process for the plus minus switching, plus or minus switching. However, the electrical switching is different, where multiplication of the regulating range can be achieved with the arrangement of multiple coarse changeover selector, which connects or disconnects the coarse winding. This scheme is much more cost extensive, as because it has to provide separate coarse and fine tapping windings. The coarse fine regulation is to arranged in a way where the voltage regulation function is split into two windings, one for the coarse step and another is for the fine steps. In this arrangement, load losses in the minus part of the regulation range would be less as compared to plus part of the regulating range. See the diagram. In coarse or fine switching, the changeover selector that would have to extend the regulating range to twice the voltage of the tapped winding by connecting or disconnecting the coarse regulating winding. One is even position, another is odd position. Or that resistance, this resistance R is the transition resistance. Resistive type load tap changer. These two are the resistive element to limit the circuiting current when in the bridging position. When changing from the end of the fine winding to the end of the coarse winding, again I repeat, when changing from the end of the fine winding to the end of the coarse winding or vice versa, with resistor type tap changers, a high leakage inductance might appear with the two windings in series opposition. This high linkage inductance may lead to cause a phase shift between the switched current and recovery voltage of the diverter or selector switch. The resultant effect would be an occurrence of extended arcing of the switching process. To avoid such phenomenon of unrestricted arcing process, it is necessary to mention the leakage inductance value in the ordering dataset during the time of procurement action. However, it is better to consult with the manufacturer, and that must be in accordance with the standard IEC 60214-2. Let's stop here, further to be continued at later stage. Thank you. Thank you for patient hearing. Kindly do like, share, and subscribe. Your subscription would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section. Thank you.